Myself, Dr. V. Srinivasa Desigan, Associate Professor in the Department of Sciences and Humanities from Vignyan Foundation for Science, Technology and Research University. So what is the scope of this particular subject, Physical Pharmaceutics 1? The course deals with the various physical and physicochemical properties and principles involved in dosage forms and particularly in formulations. Theory and practical components of the subject help the student to get a better insight into various areas of formulation research and development and stability studies of pharmaceutical dosage forms. What are the objectives of the subject? Upon completion of the subject, you are able to understand various physicochemical properties of drugs, drug molecules in the designing the dosage forms, know the principles of chemical kinetics and to use them for stability testing and determination of expiry date of formulation. And the last one is about the demonstrate use of physicochemical properties in the formulation development and evaluation dosage forms. What are the units available and topics available in the Physical Pharmaceutics 1 subjects? Or Unit 1 is talk about the solubility of drugs. Unit 2 contains states of matter and properties of matter and physicochemical properties of drug molecules. Unit 3 about surface and interfacial phenomenon. Unit 4 is about complexation and protein binding. The last unit, Unit 5, is about pH, buffers and isotonic solutions. Today we will talk about the Unit 1, the particularly topic about solubility. The solubility is very important phenomena for pharmacists and pharmaceutical sciences. For the solubility phenomenon, the following terms are generally used and very important in order to understand the solubility. The three terminologies, the scientific terminologies people are using, that is, one is solid and another one is solvent, the last one is solution. The solid is the substance which is dissolved in the given solvent is called solid. Okay, that is component, that is means compound, solid compound. The solvent, that is a liquid, the substance which dissolves the solid, that is the solvent. The solution, the mixing of these two things, solid and solvent, to become and produce the solution. Okay, solution is nothing but it is a homogeneous mixture of two or more components, that is, one is a solid, another one is solvent, mixed together and produce solution. Okay, so here you can see the solid compound. Here I just put the one example and add into the solvent and it will produce the solution. For example, in your home, you just use this common salt, right? You are in the kitchen, people used to play that, or you can, when you are preparing some of the kitchen material, you need to use the salt. When you are adding the salt into the water, what will happen? Yes, that is solubilized. Then you will get the clear solution, right? That is solvent, that is called solution. Solute, and solute is nothing but common salt. Solvent is nothing but universal solvent, that is water, aqua medium. The solute and solvent, sodium chloride, that is common salt mixed with water and produce the solution, sodium chloride solution, right? So why it is happening? In this component, the important key point, the physical phenomena is interaction. Whenever you are adding the solute into solvent, solute-solvent interaction will be happen. So once it is interaction is successful, then we will get solution. That is what I just given. This common salt, sodium chloride, at molecular level, it is called NaCl. That will interact with water molecule, H2O. I represented, that is a red color ball is about oxygen. The two white ball is talk about the represent the hydrogens. Okay, so two hydrogens, one oxygen. So water molecule, water and sodium chloride interaction and produce the solution. So solubility, what are the definitions people are talking about? The solubility is defined as amount of substance dissolved in a given quantity of solvent, right? That is the solubility definition. So we can define the solubility in two different ways. One is quantitatively we can define, and also we can define in terms of qualitatively. If we go for quantitative statement, what is that? It is talking about quantity, how much amount of solid, that means salt or given compound, dissolved in the given solvent. That is called quantitative definition. That means solubility can be defined as the concentration of solute in a standard solution at a certain temperature. If in terms of qualitatively, if we talk about, that is spontaneous interaction between two or more substances to form a homogeneous molecular dispersion. Homogeneous means that particular compound is dispersed in entire part of solvent. Okay, it's not like a heterogeneous, it's a homogeneous. That means the concentration of the solid is equal at all the places. That means the solid molecules are dispersed in the solvent in all the places equally. That is called qualitatively, and other thing is about homogeneous solution. The solubility concept is an important for the different branches of science, including physics, chemistry, and particularly it is very important for the pharmacist, because in the formulation unit we need to understand, in order to work in formulation unit, we need to understand the concept of solubility. Okay, so in pharmaceutical science it is most important because the bioavailability of the drug depends mainly on the solubility. If the compound or the drug, or in another terminology inhibitor, is not soluble, then that entire system will go is useless, and we cannot use that compound for that further study or further useful for the biological activity. As you see here, this animation, the solid is added into the solvent, then it will get dispersed. You can see these molecules are getting dispersed into solvent and start the interaction with the water. Then finally we are getting this final solution. So solubility is the phenomena. To understand the phenomenon of solubility helps the pharmacist in different ways. I gave 5 different ways. The first one is select the best solvent for your drug or mixture of drugs. The second point about overcome the problem arising during preparation of pharmaceutical solutions. The third point about the important is have information about the structure and intermolecular forces of the drug. The fourth one is about many drugs are formulated as solutions or added as powder or solutions forms to liquids. The fifth information about drugs with low aqueous solubility often present problems related to their formulation and bioavailability. Okay, in order to understand the phenomena of these 5 phenomena, we need to understand the solubility. And there is another concept, boiling point and melting point. This is you studied in the intermediate level, right? These 2 different terminologies. Why the water is get boiled or start to boil at 100 degrees C. I think you are in the kitchen, when you are just taking the water and put it in the stove, then it will start to boil after a few minutes, right? It is the temperature is about 100 degrees C. This is what you studied in the intermediate. Why the water boil at 100 degrees C? What does it mean? That means we are giving the energy in terms of fire, then that water molecules are in the liquid state. It is showing this, it's sitting in approximately and is very close proximity, the water molecular interactions. Once it is almost, if you see that at the molecular level, one water molecule and another water molecule distance is the hydrogen bonding distance. People used to say that terminology, water molecule interactions, that is hydrogen bonding distance is 1.9 Armstrong or 2.0 Armstrong distance. So while we are heating up, what will happen? This water molecular interactions will be broken, and this water molecules is move away and go to the next state, that is gaseous state. The same thing is happening for melting point. If you see that melting point, usually for many compounds it is high, because the solid compounds are, all the molecules are sitting very close proximity, is tightly packed. So in order to break the force of attraction between the ligands or between the molecules, we need to provide the huge amount of heat in terms of either temperature, huge amount of energy in terms of temperature, or in any other external force we need to give in order to break this particular force of attraction. So that once it is broken, then it will go to the next level, that is from the solid compound to liquid. That is called as melting point, where that solid compounds start to become a liquid. That temperature is called as melting point, right, of the particular compound. Based on the solid dissolved in solvent, again solutions are classified into 3 different categories. One is gases in liquids. We can dissolve the gas in liquids. Ammonia, for example, dissolved in water, what we can get? Exactly, ammonium hydroxide. So liquids and liquids, example, 2 liquids which you can take. One is alcohol, another one is water, we can mix it. So that is called liquids in liquids. 2 liquids are just mixed each other. Another one is solids in liquids. As I started that in the beginning of the class, I said sodium chloride in water, right? That is salt. that is solid, liquid is a water, the salt put in the water. That is one of the best example for solids and liquids I gave here. Another example is potassium hydroxide is the compound dissolved in water. And then classification of solutions based on the saturation, that means how much amount of solute dissolved in the given solvent. Again, these are further categorized into three types. One is unsaturated solution, second is saturated solution, third one is supersaturated solution. What is unsaturated solution? Solute concentration is low, that is unsaturated solution. Okay, the solute concentration is low. That means solvent is capable or have the capacity to accept more amount of solute, right? That is unsaturated solution. Saturated solution means that is already reached the solvent, the threshold point. That means both the concentrations of solute and solvent are reached the equilibrium, right? So there is no more vacant place to accept more amount of solute. The third one is supersaturated solution. Solute concentration is high. That means it exceeds the amount of acceptance of the solvent. It is exceeded. That's we can, if you add more solute, that will be showing or existing as a solute molecule or the compound in the solution. That is supersaturated solution. I just shown here as a three different pictures. The first one is unsaturated solution. You can see a very clear, crystal clear solution. Still, that solution is actually having the solute and solvent. That is solution. The second one is saturated solution. Here solute concentration and solvent concentration all are reach that equilibrium. The third one is supersaturated solution. Here that solute molecule, you can see the more amount of white color, that is nothing but salt compound, that is solute. It is exceeded the capacity of the solvent, that is supersaturated solution. So the next topic terminology about in this particular topic is thermodynamic solubility of drugs. What is the thermodynamic solubility of drugs? Before to enter into this picture, could you tell me some of the thermodynamic parameters you studied in the school in your intermediate? Yes, enthalpy is the thermodynamic parameter. Gibbs free energy is the another thermodynamic parameter. Yeah, you are right. Entropy is the another parameter, right? Entropy, enthalpy, Gibbs free energy, these are all thermodynamic parameters. But here, thermodynamic solubility of drugs defined as maximum amount of the stable crystalline form that remains in solution in a given volume of the solvent at a given temperature and pressure under equilibrium conditions. That is called thermodynamic solubility of drugs. Here, whenever you add the solute into the solvent, that start to disperse, then solvent also just a little bit disperse and allow and give the enough space to allow the incoming solute molecule and finally produce the solution, right? The first step, dispersion of the solute, it have the delta H1, enthalpy 1. The enthalpy 2 represents the solvent molecules are a little bit moving away to give the enough space for the incoming solute molecule. The third one is delta H3 to form the solution. So delta H solution is always we just coined that, and togetherness of this delta H1 plus delta H2 plus delta H3 will gives the overall amount of enthalpy of solution. Okay, after this solubility, we need to measure the quantity of the solute dissolved in solution, okay, in the solvent. How much amount of quantity we can express in different terminologies. So here solubility expressions are three different ways people are expressing. One is quantitative expressions, okay. The second one is US people, they are given US pharmacopoeia. The third one is pharmaceutical compendia. Quantity expressions are normality, molality, percent by mass, mole fraction and molar ratio. These are commonly termed as quantitative expressions, okay. The first one is normality. I think you all studied in your intermediate level. Normality, if you know from the known normality of the compound, we can identify, we can measure or we can calculate the unknown compound of the normality, right? So what is normality? How can we define that? This is actually number of mole equivalents per liter of solution. That is called normality, expressed as capital N. Molarity is the capital M, is defined as the number of moles of solute in per liter of solution is called molarity. It expressed in terms of capital M. And molality is the small m, is defined as the number of moles of solute per kilogram of solvent. Okay, molality, small m. The next one is percent by mass, is the number of mass units of solute in 100 gram, 100 mass units of solution is called percent by mass. Then mole fraction, the fraction, that means number of moles of solid divided by number of moles of solvent and number of moles of solid is called as mole fraction. The next is ratio, molar ratio. That ratio of the number of moles of solid to the number of moles of solvent. The ratio between the number of moles of solid and number of moles of solvent is called molar ratio. The second, another point in the quantitative expressions, there are other terminologies people are using in the industry, that is percent by weight. The next is percent by volume, percent by, another one is weight by volume. Okay, weight by weight is the quantity, number of grams of solid in 100 grams of solution. Okay, then percent by volume is number of milliliter of solid in 100 ml of solution. The third part is percent weight by volume is, that means quantity of the salt or compound grams of solid in 100 ml of solution. These are the solubility expressions in pharmacy in different 3 different concentrations. Next, the US pharmacopoeia. That is the terminology was formed to create compendium of standards for the uniformity of formulations prescribed throughout the industry or throughout the scientific community and prepared by physicians and pharmacists. The solubility of a drug may be expressed in a number of ways. The United States Pharmacopoeia describes the solubility of drugs as parts of solvent required for 1 part of solid. Okay, how much amount of quantity is existing, how much amount of solvent is required to dissolve this amount of the salt or the compound. Okay, for example, here I want to dissolve 1 gram of boric acid. For this particular boric acid, 4 ml of glycine is required, as compared to other water and alcohol is not that much suitable. But if you use this 4 ml of glycerin compound, then you can easily dissolve the 1 gram of boric acid. Okay. So next, the last one is about the pharmaceutical compendia, the third expression. It describes solubility of which solid value is unknown. Okay, here we can say that during that time of this particular table is clearly explains the ratio, what terminology we need to use for the solubility of the compound. That means if the solute is the quantity of solute is dissolved in the solvent, the quantity is not known, or the value is unknown. During that time we can use this pharmaceutical compendia. For example, very soluble, that is less than 1 part of solvent required for 1 part of solute. The next is 1000 milligram of compound in 1 ml of solvent, and in this terminology same way, free soluble, soluble, sparingly soluble, slightly soluble, very slightly soluble, and practically insoluble. These are the terminologies people are using for this different range of solute soluble in the given solvent. So when the solubility will happen, the question arises, right? I'm just adding the solute into the solvent, it is dissolved. When it will dissolve? Solute, I'm just adding. Well, I'm adding into the solvent. There are 3 possibility of interactions. One is solute itself interact with themselves. Okay, solute interaction will take place. The second, given solvent, the solvent itself interact with themselves, solvent interaction will take place. The third one is solute solvent interaction will take place. So when there is a interaction between solute and solvent interaction is more than the solute and solvent interaction, then solubility will occur. Okay, what is the mechanism of solubility? The first one is, as soon as you add the solute, that will be detachment, that means dispersion, start the dispersion. The second, the solvent will create the vacant site for the incoming solute group. Okay, solute compound will come and occupy, for that solvent will produce the vacant site. After that, the solvent embedded with solute molecule, and then it will produce the solution. Okay, with this mechanism of solubility concept, I am closing this today's session. We will continue the solubility of the drugs in the forthcoming class. See you again. Thank you.